All right, we're looking at horizontal line test and how to determine if a function is one-to-one or not. We'll get to the definition of that in a second. Back in a previous chapter, we looked at whether a relation was a function or not. We had our inputs and our outputs, and as long as each input had a unique output, we were fine. This right here is a function, no problems. But when we had an input with two different outputs, that's not a function, that's a problem, because if we want to know what is f of 1, we don't know. There's a question, either 4 or 6. The way that looks when we graphed it was one point being directly above each other, same x coordinate, different y coordinates, and that gave us the vertical line test. If we can draw a vertical line that hits this function at more than one point, it is not a function. Sorry, if it hits this relation at more than one point, it's not a function. Now we got a similar idea here. We looked at this before and we decided that it was a function because each input has a unique output, but two different inputs have the same output. And that's going to be a problem for what we're looking at in this chapter, because we're going to be doing inverse functions where we're sort of going backwards from the output to the input. Here, that's not a problem. If I want to know what input gave me a 4, I know it was 1. What input gave me 5, it was 2. One input gave me a 6, it was 3. Here, if I want to know what input gave me 5, I know it was 2. But if I want to know what input gave me an output of 4, I've got some confusion here. It was either 1 or 3. And if we look at those 2 points, we see that they have different x coordinates but the same y coordinate, which means they're on the same horizontal line. So we have a horizontal line test for whether a function is one-to-one or not. This function is one-to-one, one input to one output. This one is not because we have two inputs to one output. So if we can draw a horizontal line that hits the graph at more than one point, not one-to-one. Pretty easy definition. Let's look at a couple examples. If you're given a graph, this is really easy to do. If we look at our simple graph of y equals x squared, boom. Horizontal line hits at more than one point, not one-to-one. If we look at a graph like x cubed, any horizontal line we draw hits it only one time, so it is going to be a one-to-one function. I'm not going to throw any trick questions at you, so it's going to be pretty easy. We did some trick questions back with the vertical line test, but we're not going to be doing that here. So do some examples right out of the book here. Suppose we have f of x equals 9 minus x squared. And we want to know if that's a one-to-one function or not. Go ahead and put it in the calculator for y equals, hit graph, and we can easily see, I think I can get in there closer. Yeah, can easily see that that fails the horizontal line test, so is not going to be a one-to-one function. Next one was y equals square root of x. If we put square root of x into the calculator and graph, no, that's not graph, that's graph. It's kind of half of a sideways parabola. It is going to pass the horizontal line test, so it's going to be a one-to-one function. We've got x cubed, y equals x cubed minus 9x. Try putting that in. X to the third minus 9x. Hit graph. And we see pretty easily that that's going to fail the horizontal line test, so that one is not one-to-one. That's about it. Go ahead and give those problems in the Blue Book a shot, and got one more objective for this section, and then you can head on to my math lab. Talk to you later.